it has occurred to me that I need to make a simple version of naming ionic compounds with polyatomic ions involved. So I got to go full chemistry. It's like when I turn my hat around, it's like a light bulb goes off. Or a light goes on. I don't care. Let's just do the chemistry. Okay, let's get started here. Polyatomic ions. I just wrote the definition up here. It means many. Poly means many, atomic, pertaining to atoms, but it's an ion. This is what you really need to pay attention to, is that they are ions. So it's basically a bunch of nonmetals, which of course there's a bunch of you that are going to be all like, no, there's chromate, that's a metal, but it's okay. Listen, it's usually a bunch of nonmetals that make a compound that has an ionic charge. Because it has an ionic charge, we can use polyatomic ions, basically a compound, to make ionic compounds. I'm going to put down a couple here. So example number 1 is a really important one. Okay, so this is, and so there's a 1 negative charge up here. I'm only going to just put the 1 negative. This is an example of a polyatomic ion. You can see that there is an oxygen and a hydrogen together in a compound with a 1 negative charge. This is a polyatomic ion. We can use this to make an ionic compound. Another one. How about this one? BO3 with a 3 negative charge. That's borate, right? That is, again, you don't have to memorize these. They're on a table. Another one that's really, really important is NH4 with a 1 plus charge. This is called ammonium. Okay, and they'll have these names. So this is hydroxide. I hope somebody comments that I put a capital H there, because hey, that's illegal and criminal. But that's hydroxide. It's pretty awesome. This is called borate. Borate. This is called ammonium. So really the first trick is learning to recognize polyatomic ions in compounds. Sometimes in the names you can see these ATE endings or ITE. Another ITE ending is another dead giveaway that you got a polyatomic ion. You'll notice that hydroxide has an IDE ending. That is actually an E. So that's pretty confusing sometimes, because most ionic compounds end in IDE, and molecular or covalent compounds, whatever you want to say. So it's not always a dead giveaway that you have a polyatomic ion when you're looking at the name. Yum, what's that about? Well, ammonium it's kind of like a standard ending of a cation. And you'll notice that this is super, 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 and that was 3 supers. I meant to do 4 supers, so super important. This bad boy is the only positively charged polyatomic ion that you can use. So sometimes ionic compounds can have 2 polyatomic ions if it starts with ammonium. Okay, so let's get into naming polyatomic ions. What I'd want to do first is go from a formula to a name. As you can see that we have this formula, Ca3 bracket PO4 bracket 2. Now, first of all, how to recognize a polyatomic ion that is being used in a formula. Okay, first of all, you can see these brackets. See this thing? Polyatomic ions act as 1. So you can never change PO4. That, because it's in brackets, you can't just add like a little 1 in there, or, well, you wouldn't, because that's totally criminal, but you can't add a 2. You can't change the ingredients of a polyatomic ion. Okay? Like I tell my students, if you have a junior bacon cheeseburger and you decide to, quadruple the amount of bacon, it's not a junior bacon cheeseburger anymore. It's something way more awesome. Okay? But you can't do that to a polyatomic ion just as much as you couldn't do that to a junior bacon cheeseburger and still call it a JBC. So this one right here, Ca3, this bracket is a dead giveaway that there's a polyatomic ion in there. And so that just changes the standard rules that we have for naming polyatomic ions. So what I'm going to do is I'm going to write this step by step. So you have a formula and you have the name. Step 1. in orange. Okay, what you do is you write down the name of the metal. Okay, now the metal in this case, or the cation, is calcium. So, calcium. That's what we would do. You notice how it's not a multivalent metal, so this is easy. Step 1 is totally good. Step 2. Oh my goodness, this is going to be fantastic. Step 2 is write down the name of the anion. So the non-metal here is really tricksy. If it's polyatomic, don't change the ending. No ending change. Don't change the ending. You write it exactly the way it is found on your table of polyatomic ions. I can see there's brackets. I recognize that there is a polyatomic ion. I'm going to find PO4 on the table of common polyatomic ions, and then I'm just going to write it down. This is called phosphate, so we write down phosphate. The name of this compound is calcium phosphate. Done. Over and out. Excellent. Name to formula. So in this example we have, and I sped things up, I wrote these things down. Example is iron 2 nitrite. So there is our name of this ionic compound. You can tell it's ionic because it has a metal and some sort of non-metal. It's apparent that this is multivalent. If you don't know what multivalence is, it's probably because I don't have a tutorial on this or you weren't listening. But it's okay. So what I want you to focus on, again, is identifying when we have a polyatomic ion. In this case, we have a name here, iron 2 nitrite. Now this is a very, very interesting ending. You only get ITE or ATE endings when you have a polyatomic ion. And this is fantastic because remember, most other ionic compounds, they end in IDE. So this is an easy one because we know that there's a polyatomic ion in this. So here we go. Step 1. First thing you do is write down the symbols with the charge number superscript. Superscript means up and above to the right. So iron. The symbol for iron is Fe. How do you know what the charge is? It's multivalent. Well, it's written right there in Roman numerals. It's multivalent. There's a stock system, so the charge is 2. Nitrite. You look on your common table of common polyatomic ions. The symbol is NO2 with a 1 negative charge. Oops, and so I'm just going to go 1. Now, of course, this method, here's the disclaimer. This method of the cross-down method doesn't show you or doesn't teach you why this works or how electrons are being donated or shared or electronegativity or any of that stuff. So this is just you're going to get it right if you do this. There's a lot of chemistry teachers, myself included, I don't really think that this is good for your understanding, but you're going to get the right answer until you understand. So do it if you need to. Number 2, cross down the numbers. Crossing down means this number 1, I'm going to put it over here. And this number 2, I'm going to put it over here. All right? Now, so we're only taking these numbers down, and here we reduce and rewrite. So I'm gonna note something here. I'm gonna rewrite it first. Fe. Never write the ones. NO2, but the 2 comes down here. If you leave it like that, it looks like you have 22 oxygens, and that's totally wrong. You have to put the polyatomic ion in these fancy brackets when you have more than one of these polyatomic ions in the compound. In this formula, we have 1 iron atom and 2 compounds of this nitrite stuff. Now, when you go to reduce, we're still only reducing the numbers that are subscript. There's an invisible 1 there. 1 and 2 cannot be reduced. It cannot be simplified. So this, ladies and gentlemen, is our formula. Fe bracket NO2 bracket 2. This gets challenging, but the steps remain the same. Identify the polyatomic ion, and you're well on your way. Good luck.